Astro, they are all already available with us. So what is the watch? We already had an analog watch. If I add technology to it, I have a smartwatch that was designed, and eyeglasses. So eyeglasses are normal wearable glasses that are available with me. So adding a technology, we have gotten into smart glasses. Then hearing aids. So hearing aids, we have now in mouth hearing aids, in the sense that so many hearing aids are actually outside the body, which will which so people wearing these hearing aids are actually visible, like we can see that they are wearing the hearing aids. Nowadays miniaturized hearing aids have come up. So this is one of the miniaturized hearing aids where it is not present outside the body, rather it is present within the body, in mouth, inside the mouth. They will keep these hearing aids attached within the mouth, and that will be useful for that can be used as a hearing aid also. Then activity tracker. So previously we had these stopwatches, right? So we had even for many meets and many races, sports meets and other things, we use this stopwatches for different situations. But now we have these smart watch based activity monitor and other things. And detection finally. So previously, how did we detect when we have a fever? So we just touch our body and see. It's just a perception, like feeling, right? So nowadays we have something called to be a tricorder, which can measure the temperature. Other data can be collected using this tricorder just by placing the hand, by placing finger. So this is how the wearable device got innovated from the normal wearables to smart wearables. And other than these, whatever I had spoken to you, there are different kinds of wearables that are available. So ranging from shirts, smart shirts are there. So we will be talking more about these smart shirts. And we have these Bluetooth key trackers. So Bluetooth enabled key trackers are there. We have smart shoes, smart socks, smart pants, smart belt. So name any, I have a wearable attached to it. So we can see so much of improvements in the wearable technology, which can be used for data collection, processing, and other things. Okay, now based on the healthcare setup, so we are talking more about healthcare here, right? So based on the healthcare setup, what are the different accepted wearable healthcare wearables in the market? So you know one very well, which was very much used in COVID time, right? So these are pulse oximeters or fingertip sensors. So I can just wear it on my fingertip. This can give me the oxygen concentration in my body. So this is one of the accepted wearable in the market. And we have these different kinds of smart watches, different kinds of smart bracelets, and some smart clothes. That is, these are some kind of smart clothes that are attached to the normal clothes, which can collect the data simultaneously. I also have some kind of phone attachment. So recently, this phone attachments became very familiar, right? So very famous, like some kind of sensor that is attached to the phone, and that will be used for. That can be used for getting data from these from the recording data from the body, and which can be used for further processing, that is diagnosis and other things. In addition, this is one of the important thing that is called to be as patch based sensor. This is a ECG monitor, ECG patch, which we call to be as vital patch, where we can monitor the ECG signals continuously. I hope you know what are ECG signals. Being from a biomedical background, I don't have to go deep into it. So this is a ECG patch where it is placed onto the chest, and it can continuously record the ECG signal. So these are some of the accepted healthcare wearables in the market. But what are the limitations? Now we need to come to the limitations specifically in terms of wearables. So what do you think are the limitations? First of all, I'm wearing something continuously, right? So I am using that some wearable continuously onto my body. So it will obviously provide some discomfort to me. So we have got adapted to the watches, right? We have been wearing watches for a long period of time from our childhood itself. So we got adapted to to the watches. So but if something was introduced new to our body, like for example, if I want to wear a ring which has a smart technology, then I am introducing that smart technology newly to my body, and it will provide some kind of discomfort to wear it as for a daily wear. Okay. Um, the next thing is I also have, some technology is near to me. Always there is an issue of data security and privacy, because it is always recording the data continuously, and I am not able to control the amount of recording that I am doing. Basically, wearables, we give permission, right? So even for our mobile phones, we give permission to record the data continuously. You see, Google, it is actually taking more and more data from us every day, and many of us don't know that it is actually capturing data. But still, we are able to get many things done from Google, right? So because of that data capture only, we are getting many things done from the Google in an easier way. So, but still, there is a hazard of security and privacy that is always there, where some hacking, if some hacking has been done, then our data can be easily leaked into the other to somebody else, and they can misuse the data and other things. The next one is about battery life. So always, if you are using a wearable, if you know, if you're using a smart watch, you will be knowing it very well, or else mobile phones also. So always you need to charge them. So that is also one more thing that is very important, where if you're using wearables continuously, then the charge that can be retained by these wearables will drain off, and there will be a limitation in that also. The next thing is about, we will talk about affordability. So not many people will be affordable, not many people it will be affordable to buy this the wearables, the smart technology. So because, see, for example, right now whatever smartwatch I have, that is probably it will be about 3,000 or 4,000. But as the functionality increases, that is, if I make a smartwatch that can capture the ECG signal, okay, or if it can monitor my stress levels, my activity, then the as technological functionality improves, the affordability also becomes low. That is, only very few people in the population can afford that particular technology. And the next main important thing is reliability. So I am collecting data, I am showing that my heart rate is so and so, but how reliable is that? So how much reliable my data is? You are thinking about, okay, just a heart rate, but if you're monitoring something continuously, then I need to understand whether whatever my smartwatch or whatever my wearable technology is giving me as data, is it correct? Can I rely on it? Can I make some decisions based on it? So that all those points come into picture. And there are also obviously some technological limitations. For that only we are actually improving in wearable technology. The last but not the last and the main important part in as a limitation is the factor of biodegradability. So you can see almost all the wearables currently, right now, whatever is present with us is not biodegradable, right? We are not working with biodegradability as of now. We are so there are so much of e-waste that is getting generated. So as you see, there are tons of e-waste, electronic waste, that are getting generated as part of different wearables that are currently in the market. So keeping this as one major important point, we have in our lab, we have dwelled into another part of research where we try to incorporate this biodegradability, where we try to use smart textiles. What is smart textiles? Smart textiles are something that is actually made of textile based materials. Okay, so when we have these textile based materials and we try to incorporate some properties with these textile based materials so that they become technologically advanced. So how can we make this particular textiles? What are the properties? So what we try to do here is we try to incorporate some kind of additional characteristics of the materials. Like we try to improve the conductivity of the material if we want to record some data. So if we want to record some electrical data, for example, I try to improve the conductivity of the existing material. So cotton, for example, cannot conduct, right? Cotton is an insulator. You know that very well. Cotton cannot conduct. But if I try to add some conductive material on top of this cotton, then this conductive material can give some information about about the data that is being attached to it, right? So that is how you can make smart textiles, and this is a very novel field. Right now we are currently working in the smart textiles. We are having different project going on in the smart textiles, and how this smart textiles can be incorporated into the wearable technology, right? So now, when we have wearable technology aside, and when we try to integrate these smart textiles into the wearable technology, we get an outcome as something called to be a smart apparel. Apparel means something that can be worn, as something that can be worn every day. So you can think about it as a daily wear that has a capability of collecting data continuously. So this is a very high technological advancement, right? So you have something that is worn onto your body, and you are getting gathering data every time that you are wearing it, right? And these smart textiles or e-textiles have different kinds of properties associated with them, and they require an interdisciplinary approach where you bring in electrical engineering, the some kind of electronics concepts, some kind of textile concepts, and also some kind of information science concept, that is IT concept, that is from artificial intelligence or something. So this is how an e-textile is formed. And what are the different types of e-textiles that are available? So we have three different types of e-textiles. One is passive smart textile, active smart textile, as well as the ultra smart textile. Okay, so what is a passive smart textile? Passive smart textile is something which can only sense the environment, meaning I am keeping the textile onto my body, it can record the temperature. Okay, so that is called to be as a passive smart textile, or it can record my ECG wave. That is called to be as a passive smart textile. Then what is active smart textile? Active means it can, in addition to sensing, it can also react to the environment. Meaning, I am keeping the smart textile onto the body. It is able to sense that my body temperature is very hot. So it also provides a cooling property to my body. Then it is called to be as an active smart textile. So it can react to the environmental stimuli. Then the third category is a very advanced category. Still, too much of research is going on in this category, which is called to be as ultra smart textile, where it can not only sense, it can also react, or in addition to reacting, it can adapt to that environment also. So in simpler terms, it has the ability to think. Okay, reason and other things. So then it is called to be as an ultra smart textile. And how these textile got evolved, what are the evolution strategies for these textiles? So there are three different verticals on how these smart textiles got evolved. One of the vertical is about intelligence. How intelligent is the textile? So primarily we have these traditional textiles where the textiles that currently we are wearing. Okay, so they don't have any smart properties. They are just a textile that can be used for as a clothing. Okay, the next kind of textile is a passive smart textile, which we have already seen. The other form is the active smart textile, and the next one is the very smart, ultra smart, or very smart textiles. The other category or the other vertical is about the degree of integration. How am I going to add these textiles into the daily wear? So that is what is called to be as a degree of integration. So there are four generations to it. Currently we are on the second and third generation, where first generation is actually when we attach these smart textile to the exterior of the clothing or wearable. Okay, so you take a regular wearable and attach these smart textile to the exterior. Then that is the first generation which came up, and the second generation where we try to incorporate it onto the within the textile itself. For example, I sew some what is that conductive material as an embroidery pattern. Okay, so this forms the second generation where we try to formulate different embroidery patterns which are made of conductive materials, and they can extract some data from the body. So this forms the second generation. We are still working on this also. And the third generation involves the integration of this smart textile, integration of the conductive material as a yarn or fiber itself. Meaning, it is not sewed also. It is already integrated when the clothing was, or when the textile is made, when the cloth is made. So it is actually integrated within the yarn or fiber itself. So there is no external external conductive fiber that is taken and that is added. So it already comes with the textile material itself. So that is the third generation. The fourth generation is something which is highly in a developmental stage, which is actually, it is directly present on the body. Okay, so or on the skin. So we right now we have something called to be as e-tattoos. I don't know whether you have heard about them. So e-tattoos or e-skin, e-tattoos, something like that. So which can be it is like a small tattoo like structure which has electronics also onto it, that can be directly attached to the skin, and it will be used to um, monitor the data, whatever data I want to collect. So these are the different degrees of integration, and there are degrees of self-sufficiency also which have evolved. Whereas we have different dependent or unsustainable material, self-sufficient material, and here in the future we are going towards the intelligently self-sustained materials. Okay, so these are the different kinds of evolution that happen in the smart textile. And application point of view, if you see the application, there are many kinds of smart textiles that have been used. So this is how I have this is one of the small examples where it is actually integrated into the clothing. So we can use it in healthcare as a life belt. In defense also people use it nowadays. So we use smart clothing in defense also. As a life jacket we can use with technology as a smart textile. And you can see that it is actually improving. The wearable devices using smart clothing is actually improving day by day. In 2017 only 4.1 million market was there, and in 2022 it has improved by 5 times. About 20 million is in the market. So it is actually improving in a very huge rate. So smart textiles research is also going on in smart textiles, and it is also improving in a very huge rate. Now, what are the applications of these smart textiles in healthcare? So where do we use it? So primarily we use it for biosignal monitoring. So biosignal monitoring, in the sense, I use it to record ECG signals, EEG signals, EMG signals, and other things. We can also use it as a UV protection. So how UV rays can be protected using this smart textiles. It can also be used for its antibacterial properties. So so how it can protect us from the invading bacteria and other pathogens in the air. And it can also be used as a smart socks. So for other gait analysis and other things. Okay. Now, when we go in for this smart textile, so smart textile as a sensor development, how this smart textile can be done. So we have already spoken about this a bit. So these can be weaved, knitted, or embroidered using these conductive yarns. So I have different kinds of conductive yarns available, and these can be integrated into the smart textile using weaving patterns, different weaving patterns, different knitting patterns, embroidery patterns, and other things. And different types of conductive materials can be used, like silver, copper, stainless steel. All these things can be integrated as threads or yarns with the normal textiles, that can improve, that can provide conductivity to the normal textiles. Okay, but more than this, appropriate signal conditioning circuit is essential. Why signal conditioning circuit is essential? Because if you can imagine, these are the normal ECG electrodes that are available in medical field, right? So I hope you would have seen these electrodes. So this is a normal electrode, a bulb electrode, or a suction electrode. So which has been used for monitoring, which has been used for recording the ECG signals. And nowadays we also use this patch-based electrode. So these patch-based electrodes are currently used in the medical field even now to record the ECG signal. But what do you think are the disadvantages of these current? Yes. Okay. Sorry. Okay. So for these patch-based electrodes are mainly used for to get the data recordings in the current medical setup or healthcare setup. Right? So as of now, when we look into this patch-based electrodes, when we are recording the ECG signal. Right. So what happens is we need the person to be lying down in a stable position. He or she should not move. That is a major important thing in any ECG recording. Correct. So when we use this kind of recordings, when we use this kind of setup, then in comparison to the smart textile, this requires stability. But in a wearable technology, we cannot a person to be stable. That is not at all possible. My user, whoever is using this particular technology, will always be moving. He will not be staying stable in one position. So that is also one more important aspect when we need to consider when we are looking at developing a smart textile based wearable technology. So you need to design an appropriate signal conditioning circuit for continuous monitoring of the signals. And there are many different kinds of smart textile based sensor developments that have been in the market. So this is a wheelchair that has been developed using smart textile. So a person sitting on it, he need not have any electrodes on him. He can directly sit on it and the ECG signals will get recorded like this. So this is another electrode which can be used as a belt. So this belt, this is a belt that is worn on the person's chest that can directly record the ECG signal. So this is another jacket that is actually developed by some researchers in NC State University. So these jackets can also be used to monitor the ECG signals. Now, so what we are doing right now? So what we are trying to do is we are trying to get some textile based electrodes which can act as a alternative for these patch electrodes. Okay, so currently we have this cotton fabric, where we try to incorporate another conductive thread into this cotton fabric that can act as a electrode for this conductivity, and it can measure these electrical signals. So this is setup which we have done. We have it's in our lab. We have done this setup, and we have used these kind of measurements to record the electrical signals. You can see the electrical activity of the heart. It's almost, we are getting very good results. And this is, if you can see, this is a setup that we have done, and you can record the electrical signals with this setup also. So now the next thing where the integration of artificial intelligence in the wearable technology. So this is where we bring in different kinds of approaches, right? So why artificial intelligence needs to be incorporated into wearable technology? First is the data. So something we are measuring continuously, right? We are monitoring, recording continuously. So the amount of data that we are getting is huge. So to understand and analyze this amount of data, we need some kind of artificial intelligence incorporated into this technology. And nowadays, right now, global AI wearable market, so AI integrated wearable market is actually improving a lot, and it is estimated that in 2027 there will be a huge improvement in the AI based wearable market, because right now we are still in the research stage. We are going to integrate these things, right? So, and what is the need for this AI integration? First of all, we have a improved user experience. Accuracy will be improved because we are incorporating AI technology. So the diagnosis and other prognosis and other things, accuracy will be improved, and real-time monitoring can be done. I don't have to wait for a doctor to read my data, understand my characteristics and other things. AI can give me that in a very simpler way. And there are increased life expectancy because AI is able to understand my data very well. It can give me solutions also. So those things are having a very high improvement in wearable technology. So this is a buzzword where wearable technology, artificial intelligence, if it is merged together, then the world will see a huge improvement. So currently we are doing it, but still there are much more things that needs to be integrated in the AI point of view, where we can have things like telemedicine and other things, where integration of IoT is also there. We will talk about it in a bit. So integration of artificial intelligence is highly introduced. So how can we introduce this artificial intelligence, and what kind of approaches we have to take? So first is machine learning approach. This is a very traditional approach. So how we can use this machine learning approach in integrating the artificial intelligence with wearable healthcare. So I have a data that is continuously getting recorded in a real time way. So I need to pre-process this data in a real time. So that is very, very essential, because I am getting continuous data, but this data may or may not be good enough for analysis. So I need to do a pre-processing in this particular stage. So pre-processing of this, I have given a basic example of ECG. You know this very well. So it is actually corrupted with different noise. Probably this is a 50 hertz noise which we are talking about, electromagnetic interference, as well as we have baseline monitoring also associated with it. So I need to pre-process these signals primarily and in a real time. You need to understand that very well. In real time, whatever things you are doing, it is not like a static problem. So where we have pre-recorded ECG signals and we are going to do a where we are going to just clean the signal and use it further ahead. No, it is always a real-time signal where you continuously get data and it will be continuously stored somewhere. So you need to use these signals continuously to pre-process them and do other things for analysis purpose. So pre-processing is very, very essential. So there are different pre-processing techniques that we can use not to reduce noise as well as baseline calibration. And there is a important stage in machine learning approach where we try to segment out different region of interest, because if we give the complete signal to an AI, to a classifier, it will not give us good results, it will not give appropriate results. So we need to segment out the region of interest which we think that it is essential. So segmentation also plays an important role. So here I have shown an example of segmenting each wave. So we can detect the R waves and we can segment different waves, each wave within an ECG signal that is being recorded, and this also has to be done in a real time. Now, after segmenting the signals, we need to do some feature extraction techniques. So there are different kinds of features that can be extracted. You know this very well. So we can extract time domain features, frequency domain features, time frequency domain features. But all these things are good in a static point of view. But in a real time, how to extract these features is a very tedious task, right? So if we are extracting these features also, the next stage will be classification, where we try to do a supervised learning. We try to train a model and put the model in the cloud or a server, so that the model can take in the real time data and classify it into different categories and give the result based on the categories that has been classified. Now, when we are doing this traditional approach, the problem that we try to face is what kind of features are good enough, we don't know, and what kind of classifier is good enough, that also we don't know. But when we want to avoid this kind of problem, we go in for a deep learning based approach. We don't extract the feature, we don't extract the features manually. I mean to say that we do not use any handcrafted features. Rather, we use some kind of model that can extract the features by itself, and it can also use it classification. Okay, so this is a new technology that has been developed. So this is also a buzzword, deep learning, where you can integrate this deep learning models into your wearable technology. There are many lightweight models that are available which can run even on your mobile phone. Your mobile processor is sufficient to run these models, so they can be integrated into these mobile phones and other things, so that you will be able to characterize these signals into normal or disease condition or other things. Okay, so this is another technique that you can use, integrate it into a wearable technology, as well as your mobile phone, so that you can get the data continuously on the mobile phone. Now, so this is one of the work that we have done. We try to identify how the myocardial infarction means there is some kind of abnormality that is present in the heart, where my heart is not able to beat properly, contract and relax properly. So so this particular condition is very essential to be identified, or else if there is a myocardial infarction, the person will lead to a heart attack or cardiac arrest, and he will not be able to sustain. Okay, so here we try to use a particular data set that has been collected with the deep learning model, where all the 12 lead signals have been used. It's not a wearable data set also, still this model will work fine. Okay, so this was a very preliminary work that we have done, where we try to identify the whether the model is able to capture the normal and the MI ECG signal, but and it is able to capture also. But more than the model is being able to capture, I also need to understand why this model is working good. Okay, so that is also called to be as explainable AI. So we have different techniques for explainable AI. I'm just giving you a just an overview of all these things so that you can go, if you are able to get these terminologies, you can go and look into it. Everything is nowadays available on the internet, so you can go and look into it and understand better about these things also. So because of the time constraint, I'm not going deep into each and everything. So you can also do an explainability for the model. So why this model is actually working fine. So this is an explainability that we tried to do, and we saw that when we want to identify the normal and the myocardial infarction, we need to look at 2 points. One is the R wave, and the second one is the ST wave. So these two things are very very essential and on how the model is actually performing. So after the model has been developed, I will particularly look at only R wave or only the ST elevation to find out whether the ECG signal is normal or not. So that is how we can identify, we can incorporate the explainability also inside the deep learning model. Okay, now the next part is about IoT. So this is also a buzzword I wanted to introduce, because AI, wearable, AI, IoT, all these things are actually going hand in hand, will go hand in hand at every point of time. So what is IoT? IoT is nothing but Internet of Things. I have different sensors available on my body, right? So I have the smart ring, I have smart glasses, smart shirt. There are different kinds of sensors that are available on my body. I want to integrate all these things to give one good conclusion, right? So that is how this IoT came into picture, and where because of this IoT, I can have a very good healthcare setup in the society also, because I don't have many doctors available for different population in our country, right? So based on this IoT, I will be able to integrate these different smart rings, different wearable technology onto the internet to the other healthcare practitioners, so so that there will be a good amount of accessibility to the information also by the healthcare practitioners, doctors, and other persons. As well, there will be a good amount of outcome for that patient also. So that is how this IoT will improve. So this is also a buzzword I wanted to introduce, because
Ma'am, not able to hear anything. You're muted.
okay, I don't know, somebody is muting me continuously. Okay, am I audible now?
Yes, ma'am.
Yes, ma'am.
Okay, so till where you have heard, I can actually go back and explain. Have you heard about this wearable IoT? Okay.
Yes, ma'am.
Okay. So if I start from this slide, I think it should be fine. Okay. So yeah. So the FDA approved wearable IoT devices. What are they available in the market? In current market, what are the different wearable IoT devices available? So here we have telehealth based devices which can actually record ECG signals. This is a telehealth based device which can actually record ECG. You can see here, these are the two pads that are given. If you keep your fingers on these two pads, it will actually record the ECG data, and it can transmit this ECG data on to your doctor or whoever is the percent. Okay, so the next one is the PKG watch. It's also a healthcare device that is available. The that can monitor your vital signs, and this is a diabetic insole. So this is actually majorly used for identifying the diabetic wounds that are appearing on the feet. So you have different kinds of diabetic wounds that are appearing on the feet. So this can monitor and prevent these diabetic wounds, and this is an ambulance monitor. So you can see there are different kinds of leads, so ECG leads and other things that are present. So here this also you can use it for as a monitoring device. And this is a very novel device where we try to identify the seizures. Okay, so epilepsy is such a condition where we try to identify this epilepsy in an earlier, if in a within a time period. If we are able to identify the epilepsy or seizure within a time period, within a time frame, then it will be we will be able to prevent the person going into that epileptic mode. So I hope you know what is epilepsy. So seizure or fits, we call it to be, in a colloquial term, we call it to be as fits, right? So if a person is continuously undergoing this fits, he or she is continuously affected by this fits, then there will be a problem happening where he will not be able to breathe properly for a long period of time, and suddenly because of all these things there will be a possibility that he may also go into a cardiac arrest condition or brain arrest condition. Okay, so identifying these seizures in a within a time frame can actually prevent these seizures from happening, or can be managed by by some medication. So these seizures, this particular device can actually be used for this particular purpose, where we try to identify this epileptic seizures from happening. Now, if you see the market survey in wearable IoT, so there is obviously an increase, is going to be an increase uh, uh, in the growth rate for this wearable IoT, because it's a completely new field which is actually evolving. And we also have a different telemedicine based market growth also is there, where improvement in teleconsultation, based because of this COVID. So there is an improvement in teleconsultations, right? So there are many doctors who became available online. So when we need to meet these doctors, we need to get some results, some kind of test needs to be done. So these wearable IoTs can help in doing these tests and other things. So in specifically in neurology, it has improved a lot, and even now it is actually improving. The market is growing in wearable IoT also. If you can integrate all these things, it will be a huge market now. And what are the advantages of these IoT based telemedicine? So it is having a better access, cost effective. It is also convenient to use, and it will be more helpful for people, old age people who cannot move continuously, right? So if I want to take my grandmother to a hospital, it will be very very difficult, because she is in an old age where she will not be able to walk properly. So that all these things can be minimized and mitigated by using this IoT, and by using these telemedicine. So this is one of the application that we have done in wearable IoT. So this is our work that we have done, where we try to use ECG monitoring in wearable IoT. So whatever signals we have recorded using the textile-based electrodes, whatever we have shown previously, we try to use a Bluetooth wireless Bluetooth technology to store the ECG signals in the mobile and transmit it to the cloud server. So we use cloud servers for IoT basically, because we don't have that much of capability in our smartphones or in our hard disk to store that much amount of data. So it is not possible. So because of that, we use some cloud services. So we store the data in cloud services, and we process these data in cloud services. Based on the prediction or outcome of these cloud services, we will be able to give the doctors or family members an alert, so saying that whether there is any, if there is any abnormality that is present in the ECG data. So this is how we try to do the wearable IoT for ECG monitoring. So we have a 24/7 monitoring system that can actually save the data and display the graph of ECG signal, and it also give the inferences for the whatever data has been recorded. Okay, so how this has been done? We have the data, and we used some kind of pre-processing techniques to filter and visualize the data, and that has been stored and used using an ML model. We primarily used ML model. We have also used DL model, also deep learning model, also to train the model and to give some predictions. Okay, now so this is one of the one of the app that we have tried to develop in-house. So this is an in-house app which we use for a serial monitor, ECG serial monitor. So you can see that the app has a Bluetooth based connectivity. So this is a Bluetooth based connectivity that has been done, and after setup you will be able to record the signals continuously. You can see this. This is a continuously recorded signal. This is a basic signal which I try to show you, and it also gives you the instantaneous heart rate. So how much is your heart rate instantaneously? So that will also be given to the user. So this is a very this is not an absolute data. This is a raw data that I am showing. So just for an example, but we actually got a very nice ECG signal that can be captured, and that where we can have an instantaneous heart rate also displayed onto it. And even we can diagnose certain conditions where whether fibrillation is there, or whether there is any bradycardia or tachycardia. These conditions we are able to identify using this wearable IoT. Okay, so now, what are the top? Just to give you a motivation to work in this field, I have given some 5 growing startups. So you can see these people are well-known people, right? So I mean, others I don't know, but both you know very well. So they are in the wearable market for quite some time now, and there are other people also, Hinge Health, Petkit, Whittles, and Silver Trees. All these people are actually a startup based company where who are in the market, in the wearables market. So it is high time that we can also contribute to these to the wearable technology in the worldwide setup. And it is quite easy where we try to incorporate. It's just a problem that we have in hand, where we try to incorporate all these problems into the in a wearable technology, and we will be able to identify and diagnose condition, and make the life simpler also. So this is a till that is the talk for today. I have shown you different verticals in which our lab is working on. So we have different kinds of verticals. We work on image processing, pattern recognition, data analytics, electro technology, like what I have spoken today, textile based electrodes, and we also work on image guided intervention also. So these if you are interested in these verticals, if you want to work in these verticals, you are always welcome to contact me. And if you have any PhD scholars, I mean, if anybody is interested as a PhD for a PhD, if anybody is looking for a PhD in triple ITDM Kanchipuram with under me, you can always contact me, and this is my mail ID. You can always send me an email. So I'll be very much interested in getting back to you. So this is there are many projects that are going on currently. So if you are interested in joining as a project associate also, so you are most welcome. Please send your resume and please get in touch with me. Yeah. So thank you very much. Thank you for your attention. And I hope this session would have been different rather than your regular sessions. So I try to incorporate